Hi, this is Dan Maxwell, and I would like to welcome you to another episode in our series on thinking about thinking. Today we're going to be talking about induction, and I would like to start this presentation with a short definition, which comes from Pritchard's book, What is This Thing Called Knowledge? Induction. Inferences from premises which provide support for the conclusion without actually entailing it. The premises make it probable that the conclusion is true. Induction, or inductive reasoning, is the primary approach which is used in science. Here, one is never quite certain about their conclusions because we can only take a finite number of samples. Or, to put it another way, inductive reasoning is based on sample sets. Now let me illustrate this. Here's a picture of my little puppy, Casey, with her favorite squeaky ball. Casey is a little Bichon Frise. And I, for example, wish to know whether or not all Bichons love to play with little squeaky toys or toys in general. So how would I do that if I'm taking an inductive approach to my research question? Well, I've got to go out and make other observations. So what I do is go out and make a second observation. And here's a picture of another Bichon. I might go ahead and add to my sample set by observing a third Bichon. And then maybe go out and do this again and observe a fourth Bichon. Now this little guy here looks like he's got a nylabone that he's gnawing on. So I'm not sure if that's the same thing as a squeaky toy or a toy, but for the sake of our illustration here, let's say that I did observe playful behavior with some kind of toy in all four of these observations. So I could say, or one could say, that my conclusion that Bichons love to play with squeaky toys or toys in general is fairly strong. I've got a sample set here of 4, and each one of these 4 dogs was observed in some kind of playful interaction with a toy of some sort. Now, what would happen though if I were to enlarge this sample set and add a 5th observation? And let's say in this 5th observation, I observe a Bichon who absolutely does not like playing with toys. In fact, this little dog maybe avoids toys or is fearful of them. You know, in a case like that, we have 4 observations that confirm my conclusion, or my hypothesis, if you will, and we have 1 that disaffirms that. So my conclusion or hypothesis in this case is greatly weakened. I would need to come up with an explanation of some sort why we have an exception in this 5th case. As you may have already guessed, with induction or inductive reasoning, we are moving from the specific to the universal. Indeed, in inductive reasoning, one makes inferences from the specific to the universal. This is just the opposite of deductive reasoning. Now, in the episode I did on deductive reasoning, we developed what I called or is called a syllogism. All Bichons love toys. Casey is a Bichon, therefore Casey loves toys. You'll notice in that case we are moving from a universal statement all Bichons love toys to something very specific, a very specific statement about a specific Bichon. Casey loves toys. That is reversed here in inductive reasoning. In this case, we are going from specific observations. In the illustration I just finished, we had 4 observations of 4 different Bichons, and we noted in each one of those observations that the animal was playing with a toy of some sort. Therefore, it is probable that all Bichons love squeaky toys. Probable, though, is quite a bit different from completely affirmed or 100% certain. Because in inductive reasoning approaches, we may still have an observation that disconfirms our conclusion. So once again, with induction, one can never be 100% confident in their conclusion, because there might always be a single instance where the conclusion is contradicted.